Hi, let me explain to you on Fourier transform in this lecture. Fourier transform is one of the hardest concept in image processing, and this complexity is majorly because this topic is a mathematically advanced topic, and the output you get from Fourier transform, that output image, is very difficult to interpret. Now here is an image that is given, which is nothing but an array of pixels, and each of the pixels are defined by the intensity, or we call the grayscale values. So the pixels are clearly visible here, and the intensity of that is again visible, and these values or these colors are linked with values ranging from 0 to 255, and this type of images is called as a raster image in the spatial domain. So any image that is in spatial domain can also be represented in frequency domain. So when you represent in frequency domain, each image channel is represented in terms of sinusoidal waves. Now, any well-behaved function can be represented by a superposition or a combination or sum of sinusoidal waves. This is what Fourier said. This was the idea he brought up. And let us discuss about what is a sine wave and understand the properties of a sine wave in this lecture. So, here is a sine wave, and it may look like a simple curve to you, but it has a lot of implications in various fields. And you can see that a sine wave is a continuous and a smooth oscillation that repeats itself over a particular time. Now this sine wave is named after the trigonometric function sine, often denoted as sine theta, and the value of sine theta is described by the height of the point on a unit circle. When you see a sine wave, it has properties, and the properties associated with the sine wave, which we are going to explain here, are amplitude, frequency, phase, and period. The amplitude of a sine wave, as represented here with a red arrow mark, is the maximum displacement or the maximum value of a wave from its equilibrium position. It also, in simple terms, we can say that it represents the height or strength of a wave at the peak of the wave or at the troughs of the wave. So if you consider an example of a sound wave, the amplitude corresponds to the loudness of the sound. If you consider an image, the amplitude corresponds to the intensity of the pixel. Second term is the frequency. We can see that here one complete cycle of the wave is spanned over the time of 1 second. So we can say that frequency is nothing but 1 cycle per second. So it is nothing but a complete cycle or the complete oscillation of a wave that occur in a particular time period. So in this case, the time period is 1 second. So number of oscillations in 1 second, we call it as the frequency. Next, the term is phase. Phase refers to the relative position of timing of a wave with respect to a reference point. So it describes where a wave is in its cycle at a particular point of time. There can be two different waves, identical waves, one which is shifted by a phase of 90 degrees, and if the phases are different, even though the wave is identical, they will be out of sync. Now the last term is a period. Period is the time it takes for one complete cycle of a wave to occur. So it measures the duration or the time interval of the wave to repeat itself. So in this case, the period is 1 second, and there is a relationship between frequency and period. Frequency is equal to 1 upon period. Now here is another example of a sine wave. Now you can see that in this case, we have 3 complete oscillation. One cycle starting from here to here, and another cycle till here, and you have the third complete cycle. So there are 3 complete cycles spanning over a period of 1 second. Hence we can say that the frequency is 3 cycles per second, and the amplitude is the height of the wave. The height of the wave here is 2. So amplitude of this wave is 2 and the frequency is 3 cycles per second. Let's consider another wave wherein we have 8 complete cycles here. 8 complete cycles spanning over a time period of 1 second. So the frequency is 8 cycle per second, and the amplitude of this wave, that is the height of the wave, is 2 units. You can see the marked here. That is the 2 units, that is the amplitude, and frequency is 8 cycle per second. This is how a sine wave is defined in terms of its frequency and amplitude. Now, what Fourier said is, if you have waves of different frequency and different amplitude, if you sum it up, you get a new wave as seen here. So if I'm summing up a sine wave of frequency 1 cycle per second with an amplitude of 3 units, and another wave of frequency 3 cycles per second with an amplitude of 2 units, and I have a wave of 8 cycles per second with an amplitude of 2 units. If I sum this up, I'll get a new wave. The problem with this new wave is that it is difficult to analyze. I cannot say that what is the frequency of this wave as well as what is the amplitude of this wave. So how do we analyze this wave? What you get after summing up the different waves of different frequency and different amplitude? How do we analyze this? This wave can be analyzed by representing it in another form. For example, like a frequency amplitude graph, by a frequency amplitude graph. So how do we represent this wave in a frequency amplitude graph? We will see in our next lecture, so that you can understand, while representing a graph with a frequency versus amplitude, how do you equate it with the intensity of the pixel. So if you understand how do you represent it using the intensity of the pixel, it is very easy to understand the output that you receive from Fourier transform of images. So that's all for this session. Next session, I'll come up with representing this image or this waveform in terms of frequency and amplitude graph. Thank you.